When you're sick, how does your body fight off infections? Well, not like that. Actually, our immune defense system consists of many different complicated elements, such as T cells, B cells, and macrophages. Today, we're going to focus on the antibody. How do they work? How are they created? And why are they important to us? Let's find out. When we get sick, it is because a pathogen has invaded our bodies. All these pathogens present antigens or molecular tags on their surface. These antigens help the body differentiate pathogens as dangerous. Now, our body's immune system has three types of lymphocytes, B cells, T cells, and natural killer cells that combat these pathogens. To talk about antibodies specifically, we're going to focus on B cells as they produce these antibodies. A B cell's job is to identify pathogens and provide antigen-specific antibodies, which essentially lock onto the pathogen's antigen and either inhibit its functions or tag it for other lymphocytes to destroy. However, an important feature of our immune system is that the body doesn't so much as create new antibodies for these antigens as much as it matches up the antigens with the existing antibodies. In other words, our bodies rely on a trial and error way of creating a defense against pathogens by throwing antibodies against them until one of them works. Once an antibody locks in, the body produces mass amounts of that antibody. Thus, our immune system necessitates an antibody repertoire, a massive library of unique antibodies, because after all, the more keys you have, the better chance you have of one fitting into the lock. Since antibodies are a protein product, its structure is produced through expression of DNA. This blueprint basically determines how the antibody is built and therefore which antigens it can bind to. Thus, because we want the largest varieties of antibodies, the most important process in the creation of antibodies is VDJ recombination. In other words, the editing of this blueprint to create unique antibodies. The VDJ stands for the gene segments that are edited: variable, divergent, and joining. Each VD and J segment of DNA codes for a different segment of the antibody protein. Recombination refers to the mixing and matching of these parts, thus creating the genetic blueprints that can build a vast array of different antibodies. The result? An antibody repertoire of 300 billion different possible antibodies around the estimated amount of stars in our galaxy. Thus, our body is guaranteed to have antibodies that match some antigens of almost any pathogen. So, how do we harness this power in medicine? Well, your body is the most potent tool in its fight against diseases. The caveat is that sometimes it takes a long time for your body to find the right tools. One way we can help is through vaccines, which give your body time to find the right antibodies without the severe symptoms. Another way is through synthesizing monoclonal antibodies, or cloned antibodies that target specific antigens. Basically, this gives that middle step of looking for the right antibody and begins the immune system response right away. Thanks to these inventions, some diseases are becoming more treatable and others altogether obsolete. And yet, there is still a world of potential to be found with the numerous antibodies your body produces. You carry a whole galaxy of antibodies within you. Perhaps you can explore and find the next new breakthrough.